All right, section 3.1, measures of central tendency, mean, median, and mode. Nothing new. We've been doing most of this. We probably were exposed to it back in middle school, maybe even elementary school. So let's see what's going on here. Focus points, compute the mean, median, and mode from raw data, interpret what they mean, median, and mode tell you, explain how the mean, median, and mode can be affected by extreme values, what's a trim mean, and how do you compute it, and finally compute what's known as a weighted average. Price of gold, 1,200. Actually, that may be a little low right now. Zippy car gets 39 miles per gallon. I'm not sure what a Zippy car is. A survey showed the average shoe size for women is size 9. Each of the preceding statements, one number was used to describe the entire sample or population. Such a number is called an average or an arithmetic mean. Many ways of computing an average. We'll study the three major ones. The easiest of the three is the mode. Count the letters in each word of the sentence to give the mode. The numbers of the letters in the sentence. The numbers of letters in the words are 5, 3, 7, and so forth. Notice there are more words that have 4 letters than any other amount of letters. So in this case here, we would say that the mode is 4. For larger data sets, it's kind of useful to maybe sort the numbers. If you have, let's say, 20 or 25, you want to maybe sort them from smallest to largest to pick out the number that occurs most often, the value that occurs most often. Not every data set has a mode. For instance, if I give an equal number of A's, B's, C's, D's, and F's, there is no modal grade. In addition to that, mode's not very stable. Changing just one data value changes the mode drastically. However, the mode is a useful average when we want to know the most frequently occurring data set. I'm thinking about retail. Obviously, in a store, let's say a clothing store, men's clothing store, you would stock more of a particular size than another. When I used to work years ago in college at a men's store, 34 waist was the most popular, so we stocked more of that. So this is an example where the mode would be useful. So if you're in a grocery store, you're going to stock the items that are most popular more than the ones that don't sell. So we need to know the mode. Another average that's useful is the median or the central value. Many times it's used in real estate. Find the median home price. Let's say, for instance, I'm moving out to California, let's say San Diego, and the median price of homes is $350,000. If that's the median, I know that there's an equal number of houses that sell below that as well as sell above that. All right. When you're given the median, you know there are an equal number of values, like I just said, above and below. When finding the median, sometimes you're presented with an odd amount of numbers. There's an exact middle one. If you have 9 values, the 5th one is the middle one, provided you've sorted these from smallest to largest. Doesn't make any sense to find a middle number if you're not going to sort them. If there's an even amount of numbers, like 10, they're going to be 2 even numbers, all right? 2 middle numbers, the 5th and the 6th. What you would do is have to add those 2 up and find the average of those 2 numbers. Odd amount or even amount. These are prices of barbecue flavored chips according to Consumer Reports. And we're interested in finding the median, the middle number. But notice initially they're not in order. So we would sort them into order, 18 being the smallest, 35 being the largest. Since there were 6 numbers in even amount, there are 2 middle ones. So locate the 2 middle ones, 19 and 27, add those together, divide by 2. The median would be 23. Notice 23 wasn't even part of the initial set, but when an even amount, you have to find the average of the 2 middle ones. We have an odd amount. It's pretty simplistic. 5 numbers in order. 19 is the middle number. That's the median. No big deal there. Median uses position rather than the specific value of each data entry. If the extreme values of a data set change, the median usually does not change. That's why we use it for prices of houses. You get a mansion selling for several $1,000,000 at a much lower price. In a community with much lower price homes, the median of the houses would not be affected by that extremely high dollar value house. For small data sets, we can scan the set to find the location of the median. However, sometimes you're presented with a lot of numbers like 99 or 100. You say, well, what's the middle number? What you would do here with a large data set, you take the amount of numbers you have, you would add 1 and divide by 2. For instance, if you had 99 numbers, an odd amount, this is an exact middle one. Take 99, add 1 divided by 2. The 50th value would be the median, provided you get these things arranged in order. If you had 100 numbers, take 100 plus 1 divided by 2. You get 50.5, and that tells me that there's two middle numbers, one in the 50th and the other one in the 51st position. You take those two numbers and average them out, and that would be your median. Mean, you find means all the time. I mean, you've been finding your average grade in a class. You take all your scores and your test scores and add them up, divide by how many tests you had. Provided, excuse me, in a class where you have weighted averages, and we'll talk about that at the end of this PowerPoint. Linda needs a B in biology. She did not do well because she wasn't logging onto Canvas and she wasn't. However, she did well in the last 4 tests. Yeah, okay. Compute her average. All right, so we sum up all her scores, divide by 7, and Linda ended up with unfortunately, a B minus. That's an 80. Hey, Massasoit, an 80 is a B minus. So. Oh well, Linda. When we compute the mean, we sum the given data. There's a convenient notation for sum. That's the Greek letter uppercase sigma right here. It means the sum of all the entries. There it is right here, the uppercase sigma. When we're talking about the mean of a sample distribution, we use X bar. Now, sometimes your data comes from a population, all right? Not that we find the average any differently, it's just that we use a different symbol. When someone says mu equals something, then I know that the person was working with a population as opposed to X bar when someone was working with a sample. Doesn't mean it's solved any different, it's just the notation we use. If you see X bar, you know your data was a sample. If you see mu, you know your data came from a population. Solved the same way. All right, you sum up all the values, divide by how many you have. If you're doing a population, you sum up all the values, divide by how many you have. It's that with the sample, we call the sum n, and with a population, we refer to it as capital N. Done the same way, just different symbols. We've seen 3 averages, mean, median, mode, median, and mean. For later work, the mean, from here on in, as we move through the course, the mean is the most important. Disadvantage of the mean, however, is that it can be affected by exceptional values. If we were in class face to face and I asked everybody to give me how much they made last year, then the president of the college walks in, she gives us her salary. Well, obviously it's going to jack the average up because she makes a lot more money than the rest of us. All right. So um, it's, it's not resistant to large values. A resistant measure is one that's not influenced by extremely high or low values. The mean is not resistant because a large number or an extremely small number can throw the average way off. And we're going to find out in section 3.2. This is why working with what's called the standard deviation gives us a better idea of the nature of the values. The median, on the other hand, is more resistant. However, disadvantage of the median, it's not sensitive to specific values. A measure of central tendency that's more resistant is what's called a trim mean. A trim mean is a mean of data values left after trimming out the extremely low ones and the extremely high values. It gives us a better idea of the nature of what's going on. We don't want extremely lows or extremely high numbers to distort what the middle number is. Sometimes we use what's called a 5% trim mean. Implies that we trim the lowest 5% of the data as well as the highest 5, and then we find the average of what's left. A trim mean. I won't give you any problems on that. I just wanted to expose you to what's called a trim mean. Gives us a better approximation of what's actually going on. All right, best center of measure. Well, they all have their pluses and minuses. You know, the mean, median, and mode. I'll never talk about in this textbook mid-range. These are the 3, all right? They all have their pluses and minuses. From here on in, we'll kind of rely on the mean. All right, as we move on. Pluses and minuses. The median uses position. If an extreme value is there, it's not mean. The median is not usually affected. The mode is, the number or value that's used most frequently. It's not very stable. All right, so if you have a small data set, finding the mean, median, and mode, is pretty simplistic. Sometimes you have a large data set, 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14 numbers here. All right, what I want to do in the next slide, I show you how to use your calculator to calculate the mean, the average, and the median. Your calculator will not give you the mode. All right. In fact, it looks like 178 is the mode. It's used twice. I'm looking at this twice. But the next slide will have a video where I actually work in the TI 83 and 84 calculator. And there it is right there. Okay. This one here I find gives people difficulties. All right. Notice we don't have raw data. What we've got here is a frequency distribution. You know that the amount of cigarettes that have tar in milligrams between 10 and 13 is 1. Notice we don't know if that 1 is 10 or 11 or 12 or 13. There are 15 different brands that have um, tar values between 18 and 21. Well, 15, I mean, are they 10 of them 18, 3 of them 19, 5 of them 20? You don't know. It's a frequency distribution. But we're presented with a problem. We still want to know the mean, not the median or the mode. We want to know the mean of this frequency distribution. What this entails is, since you don't know this one represents a 10 or 11 or 12 or a 13, what we do is we split the difference. We find the class midpoint. How do you find a class midpoint? You say 10 plus 13 is 23. Half of 23 is 11 and a half. Now, I don't have to keep on doing it, adding 17 and 14 divided by 2. I see here that the class width is 4. So once I figure out the first class midpoint, 11.5, I keep adding 4 all the way down. There's no way of getting around. When you're given a frequency distribution, guess what? The word frequency will be there. You'll have two different columns. You've got to. You can't get around it. You got to take these classes and find the class midpoints. It involves some work. I see people get this wrong all the time, and they're just, I'll be very blunt, they're just lazy. They don't want to find a class midpoint. They wonder why they get it wrong. Well, duh. All right. You got a formula here. We really don't want to get involved in, the summation of all the frequencies times x divided by the sum of the frequencies. We don't want to do pencil and paper. We want our calculator to do this. All right. Now I'm just following through with what you would do if, I was mean and wanted you to do this pencil and paper. It takes a long, long time. All right. We're not going to do using this formula. We're going to let our calculator do all of the work. So I've got two frequency distributions here. How do I know it's a frequency distribution? Maybe the word frequency gave it away. All right. So there's a video here that talks about it, but I'm going to do my own video. No harm in watching that one there. Midpoints. There they are. All right. And then the midpoints for the first. Notice, I notice the class width here is 10, between 60 and 70, or 70 and 80, or 99 and 109. Remember, class width is the difference between any one upper and the next upper, or any one lower and the next lower. It's consistent. So once I found this first midpoint, I took 60 plus 69 divided by 2. I got 64.5. All I had to do is keep adding 10 to class width. All right, so there's a video where I walk you through how to do it with the calculator. All right, here are the answers. He's doing it pencil and paper. All right, make sure you watch that video. It kind of simplifies the whole process. This is interesting. Students often tell me, oh, my chemistry class, my lab counts for so much, my homework counts for 20%, attendance is 10%. You've got what's called a weighted average. And then I ask the students, well, can you figure out the weighted average? Do you know the professor actually calculated your average properly? No one knows how it's done. And worse yet, not only they don't know how a weighted average is calculated, they don't even bother asking the professor. Silly, weighted average. Sometimes we wish the average numbers, but we want to assign more importance or weight to some of the numbers. Suppose your professor tells you your exam grade is based on a midterm and the final exam each is based on 100 points. However, your final is 60% of your grade and the midterm only 40%. How could you determine your average? All right, there's your raw score, 85. It's worth 40%. There's your grade, 94. On the final, it's worth 60%. All right. What we're doing here, it's the numerator is the summation of all your raw scores times their weights. Now notice, with 40%, I changed that to 0.40. 60%, I changed that to 0.60. So I'm adding up the product here of the score times the weight plus the score times the weight. Now, interesting enough, the denominator is the summation of all the weights. In most examples you'll see here, the summation of all the weights will be 1 because it's 100%. But the misnomer is it doesn't have to be. You could have a weighted average where the sum of your weights is 140%. It'll still work out appropriately because it's a ratio, it's a fraction. But what I'm telling you here, most problems you see here, the denominator just works out to be 1 because the summation of the weights is 100%, which is the number 1. It doesn't have to be. It doesn't have to be. That's the idea I'm trying to say. But in the problems you see, most of them do work out to be 100% or the whole number 1. So there's the formula. It's the summation. All right, you're going to add the raw scores times the weights divided by the sums of the weights, which in most cases add up to 100%, which is the whole number 1. Suppose your midterm score is 83, your final is 95. Midterm's worth 40%, your midterm, and I'm sorry, 40% for the midterm, 60% of the final. By the formula, we multiply each score by its weights and add the results together. There's the score times the weight added with the score on the final times its weight divided by the sum of the weights, the point for 40% and the 60% change to decimals. Notice this is going to add up to the whole number 1. 33.2 plus 57, you earned a 90.2. You get an A minus. Well, he says A. Good luck. All right, hope that helps. We're looking for an exam real soon. To be quite honest, I'll let you know on Thursday's moment, but it's looking like in a week or so.